All right. So we covered a lot of ground in part one, right? Um, Creating a Git repo, adding, committing, checking Git status. To briefly go back to like my favorite diagram of all, this one showing the three possible states that any that code in a Git repo can be in, right? Unstaged, added or staged, and then committed. And we talked about Git commits and how each commit captures changes to one or more files, which indeed, like folks were saying, are tracked separately from the files themselves in our file system in that .git directory, kind of like a database. And each commit points back to a previous commit. And Git can kind of Lego all these little changes together to build up the whole picture of, all the current state of a file and a code base. We learned about this special variable head that points to the most recent commit on a branch. And in fact, that should be up here because we also learned about merging branches where I can create another branch that has its own commits and the commits of the parent branch, the branch we branched off of. And then I can also merge them to bring those commits onto the parent branch. And
I
then
guess I
we
do
we
have a question.
yeah, absolutely.
Uh, just with the way that you explain that. So when you merge that branch into main,
Yeah,
if it had commits after where we initially made the first branch at my feature,
yeah,
um, and then you still merged it, like what would happen?
yeah. Great question. What would happen is those commits would be on the other branch, but they would not be on main.
Okay.
So yeah, and in fact, actually, that's a great thing to demo right now, real quick. So let me go ahead and check out main. Let me close this README file so it doesn't confuse us. And we can see here, if we look at the log, remember these two commits were originally on my feature branch. Um, Let me make sure I'm in the right directory. Yeah, I should be in the right spot. I'm not sure why that virtual environment got activated. And if we open up Git graph, we can see, let's just look at the main branch and we can see all of our changes here. If we look at my feature, it looks awfully similar, right? Let's, just like you were saying, let's check out my feature. Let's open up maybe example.py and let's add print goodbye moon. So now we've got here, and I think I forgot to put this. I think this should be over here as well. We sort of have both of them. Um, so it doesn't actually make copies of the commits. It just sort of changes like where they point. Like in fact, I'm pretty sure the way that the merge happened was simply, if you think about where these arrows go, it kind of looks like that. But what we've done now is we've added another commit on, and remember, here we're sort of seeing main, and here we're seeing my feature, and we've added this other commit here. And if I open up the Git graph, we can see see if we see main and my feature. Yeah, it doesn't do a great job of showing us on the graph, but if I just show us my feature, we see that this is there. If we hop to main, we see that it's not there. And in some ways, git log might be a bit easier here, because if I do git log for my feature, we see our new add goodbye moon message. But if I check out main, we see that it's not there. Right? So it's not sort of like they auto update. It's like when you do merge, whatever commits are on the branch at that time get merged. And I know that like this sort of style diagram can be a bit confusing, and it's a bit confusing to think about like each commit pointing back to its previous commit as well. But I think this is a good way to think about it. And if we kind of were to make a drawing of our main branch, we'd start here with the head, right? It would point back to that one, to that one, to that one, to there, and finally to our very first commit. While with feature 2, now that we've added this new one, we've got that. And I apologize. I think I have a little bit of a mistake here because I think this is. I kind of copied stuff over before, which honestly made it a little confusing. You can think of this as being like a big pointer because sometimes what you actually have is they call it a merge commit. We actually didn't need it in this case. And really, this is like main head. And let's make this my feature head. And let's make this purple. And this one can be red. Sometimes you see a merge commit here, but so main is really pointing to this one. And so it just depends how you want to draw it, right? But you can see it's the same commits and they all point to like the same previous commits. But if we kept adding different stuff here, indeed, my feature would become like more and more different. And then if we wanted to, we could merge this to main. And similarly, if I started adding more stuff onto main, it would become more and more different, right? Which is why there's a lot of like workflows that get developed to manage this stuff. And sort of the rule of thumb is you kind of want to merge to main a lot to keep it up to date. Because if it's just you, it's not too bad to keep track of this stuff. But if you have a team of 5 people, it can get messy really quickly. Um, so I apologize if that got a little confusing, but that was a great question. And the short answer to the question is yes. If we add more stuff to my feature branch, it'll be on the my feature branch, but not on main branch. Yeah, great question.
Real quick, to kind of go
Yeah,
off on his question.
yeah.
So when you merge, do all the commits previous to the merge on the secondary branch carry over to the main branch?
Yeah, so that's where it gets a little funky. Nothing gets copied. Um, it's think of it as we haven't really talked about the linked list data structure, but each commit has a unique hash, right? An ID. And just remember that each commit knows the ID of the one before it, of its parents. So when I merge stuff onto main, I'm not actually copying commits. Um, all I'm doing, and let me get rid of this stuff here. Let me get rid of this stuff here so we don't confuse ourselves. And this is a bit more advanced. You guys don't need to worry about this right now because this is getting more into the guts of Git. But so this is kind of our situation before the merge. Remember, we had these three commits on main, and then on my feature, I added a goodbye moon message and I created a new file. When we merge in this specific situation, because there's no extra work on main, right? Like there's not an additional commit here. And even if there was, it would depend on if it interacted with these files or not. All we're really doing when we merge is we tell main, hey, your head is now here. It's the most recent commit over here. And then main can work its way back like that. And my feature branch can work its way back like that as well. If we had another commit on main, like I don't know, like this, where maybe we just example txt goodbye sun. And if this was our situation before the merge, then it would have kind of, depending on if these files interact with each other or not. But in essence, Git might have done something like this. It depends a bit on like if these two things modify the same file. And sometimes you can have a merge conflict where you have to manually tell Git how to deal with that. But you all will not encounter that right now. But point being, like commits never really get copied. Git just sort of like keeps track of like links to different commits. Or maybe what Git would have done is something like this. So I'm honestly not sure about that. And I think I'm probably making it a little more confusing than it needs to be right now. So I think I'll just stop right here. And also, to be honest, I'm not 100% on the mechanics because it does depend on different things. But the essence is commits don't really get copied. We just kind of change where they point to. So I'm not sure if Git would have like added like two pointers here for main and the branch or not, but it's really more just about sort of links in the chain, if that makes sense.
So would a merge conflict be like if the two of you were working on like a database file, like a JSON or something, and you both have to make changes and then just sort out the difference between the two or something?
A merge conflict would be like, let's say here on the main branch, I change hello world to hello world. And let's say I check out the feature branch and someone else decides that it should say like hello world and we should capitalize it and we're going to get a period at the end. How is Git going to know which versions of this line of code is correct? It can't, right? So it doesn't even try and it creates what's called a merge conflict. And we actually don't get into this until week 10, but basically it prompts us and we have to tell Git what version to use. VS Code kind of has this nifty merge editor thing where we can choose the one that we want. But it's unlikely you all will encounter this now because you're just working by yourself. This mainly happens when you're collaborating and like two people touch the same file. And so I would have to decide, and let's say I decide, you know what, I want the exclamation points. So I'm going to click on, where are they hiding it? I think this one accepts the changes from this incoming branch. I'm going to hit complete merge. And now if I type git status, those git actually inserted text into this file showing the merge conflict. And now that's gone. And now I can commit. So again, you all aren't going to have to worry about that right now, but that's an example of what might cause a merge conflict.
Cool. Thank you.
Yeah, totally. All right, let's talk about GitHub and the cloud. Because this is kind of the next step here where, hey, I've been working with my own repo, but it's really useful to push my code to GitHub for a number of reasons. So this is the trick question, but why do we want to put our code on GitHub? Like, why is it not okay to just have my code live here on my first repo on my laptop? And there's a bunch of different answers, and they're all simple, and that's why this is a trick question.
That y'all can see it as well.
Yeah, exactly. So that other people can see my code and use it. What's another reason?
As a backup.
As a backup?
Yeah, that way, like
Yeah.
because Git is local and GitHub's like on a server, if your computer's like stolen or broken or something happens, you still have all the work you did.
Yep, 1,000%. And for about the first 10 weeks of class, the backup portion is going to be the most important part of this for you guys. Because it's not just about what if I lose my laptop? What if I accidentally delete the whole directory? What if I somehow accidentally make, a bunch of commits I don't want, or somehow otherwise screw up my code on my computer? Well, if I've been like making a lot of tiny commits as I go and like pushing them to GitHub every 5 minutes, which is what I do and what you all should do as well, then I have a really good backup that I can get anytime. And also, what if I'm, this probably isn't as relevant for you guys, but what if, I don't know, I don't have my laptop with me? Now, you guys, might need to go through the install fest stuff again, so it's not quite so easy. But in theory, and in other situations, it's really nice to have stuff backed up like on the cloud somewhere. So again, GitHub is there for collaboration, right? If we're working as a team, it lets us see the code and share it for sharing code. And as someone pointed out, it's also there so other people can use our code, not collaborating. But say if I write an awesome program and I want someone to see it, and for portfolio reasons, because GitHub is sort of the standard, and then as a backup. And the backup one is really, really important for you guys because you are going to spend a lot of time writing code and debugging, and mistakes always happen when, you've been staring at a screen for 4 hours and you're tired, right? And you have a bunch of code. So make lots of little commits as you go. The other thing that people tend to do is not make a commit and they've got like 4 hours worth of work and something goes wrong and they haven't committed anything. And then, you're kind of up a creek without a paddle. All right. So I've got GitHub. Let's make a repo. And I'm going to go to my GitHub account. I'm going to go to repositories. I'm going to just click on new. I'm going to name it the same thing. Now that you guys have joined different orgs, you might have to choose an owner. You should choose yourself. And actually, before I get into this, I want to say this is how you guys are going to do coding assignments. So I do want you all to pay attention to this. I'll go through this flow again, I think towards the end of the lesson, but we are going to have you make copies of the coding assignment repos this same way so that you have copies of them on your GitHub and you get the practice. And we do this instead of forking for a couple reasons, one of them being practice. I have a video that I'll share as well, but this is an important step. So please pay attention. I'm just going to name it my first repo. Most of your repos you should just make public. Don't add a README, don't add a git ignore, don't worry about a license, just hit create repository. So now I've got a repo, but it's empty. If I wanted to clone it and do stuff with it, I could copy this link and use the git clone command, and I'll show that later. I think many of you have seen it, but I'll definitely walk through it later. But this is actually what we're going to do right here. These steps that it says here of pushing an existing repository from the command line. Because I already have a repo named my new repo, or my first repo, and I already have worked on it. So the same way that you'll see, a JavaScript assignment tomorrow, there will be an assignment repo. You'll want to make your own repo with the same name. You'll want to clone the other one, and I'll show the full flow in a minute. And then we want to do this step here. And let's take a look first at our setup. So right now, this Git repo on my computer doesn't have the address of any other Git repos to talk to. I need to give it the address of the repo that I just created on GitHub. And I do it with this command git remote add origin. Now, I think this URL will work for everyone. It might be a little different depending on if you use SSH or HTTPS to authenticate, but I think this works for everyone. And what we're doing is I'm telling the repo on my computer, I'm putting an address in its address book. And this is like the nickname. The same way that, in someone's address book on their phone, I'm under Adam or Adam Kahan. And then they have my phone number or my address. So this is the name, and the name is origin. And that's a convention we have to follow because Git kind of treats origin a little special. And then the address is this URL. And this URL isn't a HTTP URL. It's using a different protocol, but it'll do the same thing. And now if I do git remote -v, it prints out what's in the address book. V I think stands for verbose maybe. And we see that it has a name and an address to push code to, and a name and an address to fetch or pull code from. So now that I've done that, I can go ahead and I can type git push. And this command, just by itself, will push code to the origin. If I had multiple names in my address book, I would maybe specify the other server, but we're not going to really have to do that. I can just type git push. I'll get this message. This is okay. This is normal. And if we read this, it says the current branch main has no upstream branch. Right? And so now over here, we've added, these remotes, origin, git, GitHub, whatever. But we haven't done that for the branch. And GitHub needs to know, not just for the repo, but for the branch, what other branch to connect it to. Because up here in the cloud on GitHub, there's also a Git repo now, right, that I made. My first repo. And over here, right, we have the branch main. We have the branch my feature. There were some others, but those are the main ones. Up here on this repo in the cloud, if I kind of click on it, there's actually no branches here yet. Normally you can like see a list of branches. This repo in the cloud has no branches. So we need to both create a branch on the Git repo in the cloud and tell GitHub to connect the two together. Because just like with merge conflicts, Git is really good about being dumb. It doesn't make assumptions about stuff. And that's actually what we want. Like, you know, when you start out programming, you kind of think, oh, it'd be nice if just Git would figure out that if two branches have the same name, it should do it automatically. And then the more you do it, the more real world exceptions and things you run into. And you realize a lot of the time that actually like tools that don't try to be smart are better and more predictable. So we're going to create a branch. Upstream here means some other remote, some other Git repo. And here specifically for the origin, which we've set to be GitHub, we're going to create a branch named main and tell our local Git repo, hey, this main branch here on my Git repo, it talks to the main branch on origin. And I only have to run that command once. And I think it's pushed the commits. Yep, if I run git push, it says everything up to date. And we kind of saw here this writing objects and all this stuff. And now if I hop back over here and I refresh the page, we've got my first repo and we've got the main branch and we've got our commits.
So to be clear, if you don't specify to GitHub where in Get your main branch is, it's gonna prompt you to put in this command to specify.
Correct. Yeah. There could be situations where because of a company's naming convention, or maybe, you know, it's a remote distributed team or something, maybe for some reason I don't want this branch to be named main here. I want it to be named something else. Or maybe for some reason on my local repo, I don't want this branch to be named main. I honestly have never encountered that. I'm sure it exists somewhere. And what you guys will see is that like it's kind of like, you know, as professionals, the tools become more powerful, but they become more complex, right? And so there's more manual steps here, but that's because the tool is more powerful. It does less for us, but also it's kind of like more predictable. And in some ways, this actually ends up being good because, while this is frustrating to begin with, after like 4 weeks, this will be second nature and you won't even think about it. Let's do the same thing now. Oh yeah,
what is
what's
the
up?
get remote dash V? You said, yeah.
Yeah, that just lists our remote repos that we have names and addresses for. And this is, you know, I can make this any name I want, but if I make it origin, Git will just do some stuff automatically for me because that's sort of a naming convention. And then this is the URL to, of where the repo is in the cloud, right? Like if I go here and I go to clone, that's that same URL. And so for some of you, you might be using HTTPS if you don't have an SSH key set up. So that is one thing to keep an eye on. But you can find that URL for this repo by going to the repo and then clicking under code. And that's what we set the remote to. And this
So
just
basically to
lists
get
the settings.
our repo into our terminal, or over there is where we use the get remote and then add with whatever you want to call it and then the address.
Yeah, let's see if I hop back up. Get remote, add origin. And this is written down too in the curriculum as well for today. This is the command to actually set that address.
Gotcha.
And this just lists what we've set. Yeah.
Great, thank you.
Totally. And the way to think about it is this isn't like a persistent connection. Like here on the main branch, let me make a change to example JS. Let me add another line here. Console.log hello sun. And let me add it and let me go ahead and commit it. And I'm just going to say JS add hello sun message. Now, if I go over to my repo, that change on the main branch is not there, right? It's like kind of like mailing a letter or sending an email or sending a text in that it doesn't automatically sync, right? My repo here on my laptop has the address, but I still have to manually tell it to push any new commits to the cloud up to GitHub. And now that I've run that push command, now that changes there. Right. And I think that's a common gotcha for some folks where it's understandable to think there's sort of an automatic sync that happens where it automatically will update. And that's not the case. We have to manually push. And so if you see me write code, like every 5 minutes, I'm committing and pushing. And I'm just doing it all the time. And my commit history looks like this. And let's say for this feature branch now, I want to push the feature branch to GitHub as well. What are the steps I have to do this? So the good news here is it's
I
way
want to
simpler
say
than it
git
might
push my
seem.
feature.
Close. Even better, we can just say git push because once I check out a branch, if I type git push, it will just push whatever branch I'm already on. And we get the same message. But you know what? Now that you guys know what this is, you know that you can just copy and paste this. And it both connects, it will create the repo on the remote or create the branch. I'm so sorry. And it will connect the two. And bear with me as I probably could have done this better. Let's make this a different color. I'll just use one. I'll just use one arrow. Just don't worry about, I'll just get rid of this second arrow. It will connect the two and it will push that code. And now if I go over here and I look at my repo, here if I look at the branches, I've got my feature. I can see that commit history there on my feature.
By the way, where it says the command to use git push set upstream origin right afterwards, is that the name that you are setting as the branch in GitHub, or is that the one that you're telling to push upwards?
Yeah, that's a great question. I'm telling Git to I'm telling Git to for the my feature branch. In GitHub. So in fact, let me go to the TL draw. And let me get rid of this because that annotation is probably confusing. And I'll be honest, I'm a little rusty on the exact mechanics here, but I'm pretty sure that set upstream origin. So first off, origin is our address nickname, right? Because 99% of the time, we're only going to be using GitHub. But if I go back to the diagram from way at the beginning of the class, Git was originally designed so that like we might be pushing and pulling code from different repos on numerous different servers or different people's laptops, like sort of a peer-to-peer network. That kind of got complicated real fast. And except for some open source projects, pretty much everyone centralizes. But that's kind of the origin of why we have like origin and different remotes and stuff. So this tells Git, all right, here's the nickname. And then Git, looks up the URL for that, which we have. If I do git remote v, we added that. So Git knows, okay, this is the URL. And then it will create a branch on that remote repo if it doesn't exist. And remember that these two are connected so that whenever I type git push for this branch, it will push that code to this repo here in the cloud and to this branch on it. Does that, I know I put a bunch of steps in there. Does that help break it down a bit? And let's actually see, because sometimes, it's good to see what other people's explanations are for stuff. Yeah, the short answer is you got to tell, if we're going to push code, the term is upstream, which just means another repo on some other server. And I got to tell Git for each branch where to send it. And I got to tell it the server, and I got to tell it the name of the branch to send it to on that server. And that's what this command does. The good news here is I literally, for like a decade, all I do, when I have a new branch, I'll type git push. It spits out this message. I just copy this and paste it and run it, and I'm good to go. And you only have to do it when you make a new branch the first time. And then from here on, like till the end of time, I can just do git push and it works fine. So this is really one of the few copy and paste operations where like you're never going to have to modify this.
I guess one thing is it feels like a couple times you've had to type in git push like a couple times to get to do what you wanted it to do.
Right. So git push, yes, we have to do that all the time. But this whole command with all these things, we don't. And git push, let's say I'm on my feature branch and I'm adding a console log message to example.js. Hello, Mars. So over here on my laptop, on the my feature branch, I now have this hello Mars commit because I just wrote it and I just committed it. But if I look here at the commit history for the my feature branch on my repo, that commit is not there, right? So how do I push the commit from my laptop to this repo in the cloud? Git push. And that's what push does. It will push any commit, it will push all the commits on the branch up to the cloud. And we do have to do that manually. And like I said, my habit is I make a commit like every 2 lines of code and I push it and I do it all day long. And we do want you guys to commit early, commit often, and push all the time, in part to get you to kind of build up your command line skills and just comfort doing this command line stuff. Not that being like command line wizards is super important to be a great software engineer. It's not. I know a lot of really good software engineers that are not, but a certain degree of comfort and familiarity is important. And so we want you to get a lot of reps and sets doing that. Also, the more advanced you get with Git, like eventually, like at your job, whenever you push code, it might kick off a series of automated tests that happen on the cloud. So the more sophisticated this stuff gets, so this is way down the line, you'll want this level of control over when you push commits to GitHub and stuff like that. How are folks feeling on a scale of like 20 to 30? If like 20 is, I don't like Git at all, and 30 is, this is the coolest thing ever.
26.
I'm right in the middle. I'd say like 24, 25.
Same.
24, 25. Cool. I dig it. Yeah,
Now,
like I said, I think that's about where you guys should be.
before
yes,
you start
someone
this
have
whole
a question?
process, yeah, I have a question. Before you start this whole process, because you started a repo from nothing on your computer, you have to use Git and Git. Is that correct? Which I did.
I did that so we could kind of learn about plain old Git all by itself. You all will very rarely do that. Probably never. Because most of the time, like these days, it just makes more sense to make the repo on GitHub and clone it. And in fact, let me show you all the flow you will be doing for the homework assignments. I have a video from a previous TI I can share with this as well. But let me show you this flow so you can get used to it. And then we'll look at the last thing for today, which is pull requests, which is really just merging with a nicer user interface. So this is how we're going to be doing homework throughout the course. And what you all are going to want to do, by the way, is you're going to want some directory, like, maybe it's Code Platoon assignments. Because you're going to be cloning a lot of repos and putting a lot of stuff in here. Some people like to organize this with subdirectories for week 1, week 2, or day 1 and day 2. Some people don't care. That one is really up to personal preference. But however you organize it, this is the flow you'll do for the coding assignments. And let me go ahead and go to tomorrow so we can have a coding assignment to look at. And let's look at this factorial problem in JavaScript. So first of all, note each coding assignment is its own repo in this Code Platoon assignments org, which you all have access to. What we want you all to do, there's a way to copy called forking. It mostly works. There's some minor issues. Right now, what we want you all to do is this, and in part to just get extra practice using Git. First, clone this repo. Then you're going to want to navigate into that directory. Then I like to just open VS Code up again in there just to get the Explorer window oriented. I'm sure there's a VS Code command to do that without having to open a new file. I'm a bit lazy, so I just do it this way. But now, we don't want you all to work on this repo, because then all of you would be working on the same repo, and you're going to be, adding code here, and there's going to be some tests you'll run. What we want you to do is hop over here to your own GitHub account and make a new repository. And you can just name it the same thing as the assignment and set yourself as the owner. And I already did this once, so I'll just make the name different. And I'm going to go ahead and create the repository. And now I'm going to point this repo on my computer to this one and push up the code. Right? The same way we just walked through this here, we're going to do this with the assignment. So I'm just going to copy this line and air remote origin already exists. I think we have to, the command is a little different when you have to modify it. It is git remote set origin instead of add. And we do have this documented in the curriculum somewhere, and I'll make sure to get that link to you guys. You won't need to do this today, so that's okay. And let's see here. The command is git remote set -URL origin. So forgive me. Let's try this one more time. And now if I print out my address book, I see that that's correct, that's pointing to the repo on my GitHub account now. And now I can do the same thing where I'm just going to git push. And now if I go to my repo and I click, I've got the code there. And now if I start modifying this code, and I push that, so this commit goes from my laptop to my GitHub repo on my account, we see that change where we see it here. We can see the individual commit. In fact, if someone wanted to comment on that, they could say, I don't understand. Can you explain? Should this be I can preview that markdown. I can add the comment. And I've got that on my code. And then this way the assignment is unchanged and you have a copy on your own repo. Again, we do this for two reasons. One is in the past, some stuff we do with auto grading messed with forking repos. And this way, like, you'll have this on your GitHub account till the end of time, even if we deleted this repo. And the other, to be totally honest, is to force you all to get reps and sets in on these sort of command line operations just to get more comfortable doing that. So you all will be kind of going through this flow for every single coding assignment. Pretty soon it'll be second nature. Again, we've got docs and a video on it that I'll share tomorrow. But I just wanted to walk through it today while we were kind of like introing and talking about this stuff. And I want to check in and see if folks have any questions about that flow, if that makes sense, or if there's parts that would be good to go over again.
So if we're done with an assignment, for instance, would we just send you the link then to that repository for you to grade?
Yeah, so totally send it our way. To be honest, the daily coding assignments are ungraded right now. If I'm able to, I will try to do code reviews, but it will mainly be in like team stand-ups and stand-downs starting next week, and also the class stand-down where different people every day will be demoing the assignments and we'll be doing a sort of code review and discussion. We actually, at one point, I do want to get the daily coding assignments to be a part of the grade. We have to set up some automated testing for it because, well, with the smaller class like we have right now, it's not too heavy a burden. If it gets to like 20 plus students, it's just not feasible for two instructors. But to be honest, the reason I want to make them required is because folks tend not to do all of them every day, which is understandable. We throw a lot at you. However, if I think it's really important to get at least one assignment done every day. Because as you guys can probably tell from today, like, there's no going back. You know, we're going to be using Git every day, but we're not going to have more lessons on it until we do a more advanced workshop, like in week 10 around personal projects. And, you know, we're going to introduce JavaScript testing tomorrow and not come back to it till we get into React. And we're going to introduce Python testing Thursday. Friday, we're going to talk about prompt engineering. And then all of next week is object-oriented programming. where we're just going to assume that you all can like read the Python tests that we have in the test suite. And then the assessment at the end of next week will have an automated test suite. So you guys will get a lot of practice, but the way to really learn and reinforce these things is through the assignments. And I know that that's a bit of a challenge, so I'm just going to be a broken record on that. And also be the friendly reminder, don't let the perfect be the enemy of the good. It's way better to start in on an assignment, even if you don't get it to perfection or like all the way to the finish point. The struggle is really the point, to just keep learning these skills, like learning an instrument or playing a sport. It comes through doing and practice. Let me wrap up by showing a pull request. Because that's honestly one of the coolest parts. And we also have a sort of stretch team assignment that is collaborative. And I think it'll be really cool to see. So let me just go ahead and do this on the repo that I have, so I don't have to switch. So let's go ahead and close out all of these. And we're just going to continue work here. And let's say, just for the sake of argument, I made a branch here named my feature. And I did some work. And let's say if num greater than and let's say let's add a comment there, return 0. And I don't know, I'll just add a console log here saying factorial num is, and we'll print the number. And we're going to, learn more about this next week. And I'm not going to worry too much about what this code is doing. To be honest, it's sort of nonsense code. It doesn't have any relation to the problem. I just wanted to get enough code in there so that we can see it. If I type git diff, it shows me all the changes between the current file and the last commit, right? Because all this code is unchanged or unstaged. Let's go ahead and add it. Let's go ahead and commit it. And I'm just going to say work in progress. Like 75% of my commits start with WIP for work in progress, factorial logic. And I'm going to push that code. And because this is a new branch, I get the message, but I know what to do. I just copy and paste that, and I push that up. And now if I go over here, and let me go ahead and full screen this. My feature has recent pushes 2 seconds ago. I click on view all branches. I can see the my feature branch. It says it's one commit ahead of main. In fact, if I click on this, it will show me the commit. It will show me it's called the diff, the difference. And over here on the left is main branch. And over here on the right is my feature branch. And the green stuff is what's been added and red has been deleted. If I'd modified multiple files, we would have seen multiple, file diffs like this. And this over here is where we're going to go next, is making a pull request. And you can click on this create pull request button, and this will do the same thing. But I'll show you, and this is the easier way, but I'll show you the manual way just so you know how it works. And that's to click on pull requests. And a pull request is always safe. A pull request does not merge. Let me say that again. A pull request is always safe and it does not merge. So making a pull request is always safe. So I can click on new pull request and I would choose my base or target where I want my code to end up and where I'm merging my code from. And then I hit create pull request. Now, the nice thing is this sort of pop-up, this will set all that for me automatically, again, with the correct base merging onto main and merging from the feature branch. you can add in a description here. You can add in an explanation. And I'll say, working on factorial logic. It's still a work in progress. I could add someone else as a reviewer, though when it's just my own repo, it doesn't really make sense. This is really when you're collaborating with multiple people on the same repo. And then I hit create pull request. And it might be nice to have some teammates. So if I go over here to settings and I go to collaborators, it's going to prompt me. I have to use my mobile app. And can someone throw their GitHub in the Zoom chat for me, please? And let's see here. Or can someone just tell me their GitHub?
Like the username?
Yeah, your username.
Jack, JACK dash Himlo, HIMLO.
Perfect. Thank you. So now you're a collaborator. Now, when I go to this pull request, I think you have to accept it, but then I can add you as a reviewer. And so you can go in your email and accept this. And then if you are reviewing my pull request, you could go over here to files changed and you could look at the diff and you could add comments and you could say, I'm not sure what this has to do with calculating a factorial. Could you explain? And add a comment there. I'm not sure we should comment this out while the other logic is still work in progress. Please put back. And maybe I added like a checklist item there. Keep return 0. And I use that markdown format. And I'll hit start a review. And like as a junior engineer, this is how you will get mentorship and feedback on your code. If we can, we will try to do some code reviews in the course. It's just a question of time. And here you can see the conversation and the discussion. And as I address these issues, I could actually click these boxes. I could resolve the conversation. My reviewer could give it a thumbs up. Oh, and Jack, it looks like you went ahead and merged it, which is awesome. And that's in fact, the next thing I wanted to say, which is once a pull request is approved or ready, you can hit that merge button. And in fact, this would undo that. And I can see here, there's now a closed pull request. And if I go here and I look on the main branch, we see that history, and it's that same merge operation that we did manually before, but just done through GitHub with a nice UI to review and look at code. And like to give an example of this, how many people have heard of React.js? Just to get a show of hands. Yeah, so I think most folks have. It's a really fancy UI building library made by Facebook. We'll learn it later in the course. It's open source, so it has a bunch of different repos. But if we go to the GitHub repo for React and we look at, so issues is where you can like create tasks or specify bugs. And here you can see like this is kind of why software engineering is not really about the code. Like I need to be able to explain what the bug is and how to reproduce it. Look how much documentation there is here. There's a link to a live example. There's a whole discussion around this. Like this is awesome in how strong engineering companies do their work on GitHub. And then over here we can see, let's find a close pull request that got merged. And here's one fixing a typo. And here we can see a description. We see an example of the problem. The person writing the pull request has given these examples. They link to a PR. This one doesn't have a lot of discussion. Let's find one that does. Here, this one has discussion. Where, again, like documenting and explaining to other engineers is a huge part of our job. And we see some discussion back and forth here on what makes sense. And then finally, someone gives it the thumbs up and they've merged it. So for us, for today, among your list of assignments is this Git practice assignment. Start here. Then the Git branching, where I got so lost, but they hide the
It's just in the lower left at the bottom of that gray
yeah,
box.
exactly. It's in the lower left. If I'm going to close all this stuff out just to get here, it's hiding all the way down here in the lower left. That was driving me nuts. But that's where you type the Git commands. And then, from what we learned in the second part of the lecture, there's another solo practice assignment to create a new GitHub repo and connect a local one to it, like you saw me do. And then there's a stretch group project where this is really self-organizing, but I'd love for everyone to get through all the assignments today and be able to work on this stretch one too. And you all have all afternoon to do it. Group up in Slack, and James and Max, our TAs, can help and help each group. We're going to cover this like 10 weeks from now, but learning how to read and research stuff is a big part of software engineering. So we are asking you to read up a bit on a sort of a workflow for collaborating with GitHub. And then everyone works together in one repo and just makes some really simple branches and pull requests and merges. So this is a stretch. There's plenty of stuff to work on today. And the other stuff is definitely the priority, because we might have some sort of like bonus or challenge group projects, but really until the group project towards the end of the course, you're going to be you're going to be doing tons of collaboration and pair programming in terms of Git and GitHub, mostly pushing to your own repo. So you won't have to do tons of collaboration for the next couple of weeks. So this is great, but this is a stretch. These other assignments are very much the priority and will help you practice the skills you'll need like tomorrow and Thursday and Friday and next week.
I'm still a little bit confused on pull on GitHub. Is it a request to merge, or is it testing if I'm just still confused on what pull request means on GitHub?
Yeah, it's a great question. A pull request, it is a request to merge. I think that's a good way to think about it, because it doesn't merge anything. It shows you what would happen if we did merge. Right? And if I look at this right here, I can see what would happen if I merged the my feature branch. If I merged my feature onto main, what would happen? And what would happen is all these lines of code get added, and then this line of code gets deleted.
Which one of those is main and which one of those is my feature?
Yeah. The one on the left is always the target that we're merging onto. So whatever the branch name here is first on the left in the message is going to be over here on the left. And then over here on the right is they call it the source branch. So main from my feature, main is over here on the left, and this one is here on the right. You can think of it, whenever you're looking at these diagrams, it's always getting merged that way. The code's going from right to left. Yeah, good question. And that can be a bit confusing. And initially, it pays just to go slow with this stuff with Git, because there is a lot to process and a lot of information being thrown at you. Does that help answer the question about what a pull request is?
So can you merge it, or you can't merge it?
This one is already merged.
Okay.
When you make a pull request, unless there is a merge conflict, you can always merge it. GitHub will tell you if there's a merge conflict, like you guys saw me demo before. That's not going to happen very often. But, just because you can merge a pull request doesn't mean there's no bugs in the code. I'll talk a bit more about the value of code review, but code review is really what pull requests are for. And it's to get a second set of eyes on code, because good teams know that to err is human. And the way to produce quality code is to have double checks. And code reviews are also a huge part of mentorship and knowledge sharing, so that either like more senior people can give feedback in a code review, or maybe a more junior dev reviews a more senior person's code to kind of like learn some techniques. So there's a lot of value in the code review process, and that's what pull requests are for. Does that help answer your question? Cool. And I think the last thing to show is there is a git pull command. And if we kind of hop back to my Git repo on my computer and I check out the main branch. Now, if I look at git log here, there's awesome code. But if I hop over here and let's go up to, and then we'll wrap because I realize I've ran a bit long. Let's look at these two commit histories, because this is an important point, though this is a bit more advanced. So over here on GitHub, on the main branch, we have this WIP factorial logic and a merge commit on the main branch from merging that PR. But that merge happened here on this repo in the cloud. It didn't happen here. So the main branch on my laptop doesn't have those new commits. So what I need to do now is run this command git pull. And what that's going to do is pull down, and let me make this arrow purple if I can. Pull down from the main branch here on the repo in the cloud any changes that it has onto my laptop. Now, when it's just me, it's kind of like, what's the point, right? But let's say, Jack, let's say you wrote that feature and you merged the pull request, or we reviewed it, or someone else wrote the feature, or it's not me doing the git pull. Now, Jack or Chase or Stephanie, it's you, right? This is how you get other people's code. So now I can run git pull, and we see that we pull down commits from the cloud to my local repo. And now I have those most recent changes. And now I've sort of closed the loop. You're not going to have to worry about this workflow too much now. It really only comes into play when you're collaborating. But I did just want to show this last step and the git pull command. And I realize the terminology can be a bit confusing with pull requests, and merge and all these things. But this is sort of the last piece of the puzzle that I wanted to show folks. I know we ran a bit over, so thank you. I appreciate it. Why don't we wrap up, and I can stick around for a couple of minutes if anyone has questions. It's an open work day today, so really the agenda is just working on those Git assignments. If you finish, start hitting up other folks to see if people want to work on that stretch project together. And I would love for someone to demo code at Stand Down today at 5 o'clock Central. So I will be calling on random volunteers until we find someone who can maybe just demo a bit of a Git workflow, or if our team did a stretch assignment. Worst case, I'll have something, but I think today is a good day to start having folks demo. And we'll reconvene at 5 o'clock Central for Stand Up. Do folks have any questions about the plan for the rest of the day? Okay, awesome. The TAs will be around. I'll be around, though I have some meetings in the late afternoon, but I'll be keeping an eye on Slack. And that's always going to be the best way to get me if I'm not in Zoom or I'm not responding in Zoom, hit me up on Slack. And please do follow the 20-minute rule if you feel stuck. Hit up a TA or reach out to myself for help. And if I can't help, I'll make sure someone gets in touch with you.
Will the Zoom just be like an open room, or will communication just have to happen through Slack via us personally hitting each other up?
It'll be both. Let me go
Okay,
ahead
cool.
and stop the recording, and then we can dive into that.